Hi, and welcome to Talking Tech. I'm your host, Alejandro Ojus, and today we're going to be talking about Intel's latest desktop processor, Intel Core Ultra Series 2, also known as Arrow Lake.
Well, I'm the platform marketing manager for Arrow Lake. Essentially what that means is I'm the central product truth owner for all things Arrow Lake, encompassing the entire platform.
So I'm the execution GM running the Arrow Lake program. I'm the technical program manager for Arrow Lake for the entire family. We have it on mobile, starting 15 watt all the way to desktop 250 watts. So I'm managing the entire program.
I'm Dan Ragland. My title is Senior Principal Engineer. We're here in Intel's overclocking lab in Hillsboro, Oregon.
What is Arrow Lake and what do you mean by the entire platform?
Yeah, so when we talk about the entire platform, Arrow Lake isn't just about the CPU itself. It's everything that encompasses the platform, whether it be the connectivity, graphics that will attach to it, things like the chipset, different software features, different utilities that are going to function with it. And so we sort of own, as the platform marketing group, sort of own all of that in terms of conception and then eventually bringing it to market.
Yeah, that makes sense. Mm-hmm. And so we have, for this architecture, we have three different products, right? Mm-hmm. We have Arrow Lake S, Arrow Lake HX, and Arrow Lake H. Mm-hmm. And so how do we start with S and HX? Can you tell us a little bit more about that?
Yeah, so S and HX are, specifically Arrow Lake S is our desktop family. Then HX is the sort of enthusiast mobile family. So both of them are enthusiast desktop and mobile products, sort of the top of the line for Arrow Lake. And they share the same tiles that are on each part, so they're both an 816 configuration and that kind of thing. So that's sort of the top of the product stack there. Yeah.
So it's a multi-tile processors. So,
yep.
Okay, so multi-tile. What will be the tiles that we have here for our?
Yeah. So I mean, first of all, it's the first time we've had a disaggregated part in the enthusiast segment, and so we've got essentially 4 tiles. So there's the SoC tile, the I/O tile, the GPU tile, and then of course the compute tile, which has our compute cores on it.
Moving from a monolithic to a disaggregation architectures have several benefits. It allows you the flexibility of mix and match between different process technology and different tiles. More like, if you want to up-level the discussion, kind of a Lego things, and you can replace one piece without changing the others, which help in delivering a complete portfolio, and even for the future, if you want to enhance a certain tile, that's a flexibility that it enables. In addition to that, using the disaggregation technology, we apply the Foveros to that. And Foveros technology, it's what allows us to take all the tiles and put them together into a base die. That mechanism allows us to save to shrink the overall package size of for Arrow Lake by about a third, so 33% smaller than what we had on a prior generation.
So can you tell us a bit more about the compute tile and the cores and what do we have now?
Yeah, so what we have now on Arrow Lake, specifically SNHX, we have 8 P cores. That's the new Line Cove architecture, and then 16 E cores, which is on our brand new SkyMont architecture.
Right. So we've seen these kind of brought over from Lunar Lake, right? But these have been tweaked, or? Yeah.
So there's some minor differences on the P core specifically. There's a slightly higher L2 cache on the P core, but the architecture itself is the same. You're right. Yep.
Okay. So all the different gains that we saw that from being completely redesigned from scratch are carried over to
yes,
here.
Exactly. So a lot of that's the same. When it comes to things like IPC, there's going to be obviously some slight differences because this is a completely different power envelope than Lunar Lake typically operates in. And so you won't see the exact same type of IPC stuff.
We were able to get performance benefit at the lower power. So performance per watt delivered at a much higher scale in Arrow Lake than what we had in prior generation.
So from the P cores, we have done kind of make the choice of take away hyperthreading. And that's kind of, we were talking about earlier, and we were saying like that's because of the cores have changed. Can you talk a little bit about that?
Yeah, so from the beginning of the core architecture design phase, right, where we had a set of design goals in mind. And the two main things that, obviously there's more than two goals, but two of the main things that we were talking about obviously is what really matters at the end of the day is the performance for our end users. That's the most important thing. And so the other thing we're focusing on is performance per power per area optimization. And so when we look at things like SMT and hyperthreading, obviously that was a big deal when we had one type of core, and we needed to maximize our multi-thread performance. Now that we've moved to a P-core, E-core configuration, that's not necessarily the case. And so when we think about what we're bringing to market and the type of multi-thread performance gains we're bringing over 14th gen on Arrow Lake, we're really excited to show that when we can in a bigger way. And so I don't think anyone's going to miss
the hyperthreading,
right? So it's going to look pretty good.
And one of the things that we have seen is that the performance of the SkyMon coves are amazing. And one of the changes that we did for the P-core, for the Lion coves, is like that we went ahead and we removed the hyperthreading. What's kind of the reasoning behind that, and how's that gonna work?
Since you are able to add more efficient cores and get the performance core at lower power, that will be a much better trade-off as opposed to have a performance core running on a multi-thread with higher power consumption.
One of the things that we're also talking about today, other than the raw performance, is the fact that we're delivering this performance increase, but we're also 30% less power than 14th gen. And one of the things that happens when we do these type of redesigns, and we are deciding what to keep and what not to keep, is make very important decisions in terms of that IP. And staying lean there is really what helps us deliver that power improvement.
And that also has to be done, I guess, a little bit like when it comes to the E-cores, right? Because that's kind of the new...
The overhaul was on both, the P-core, E-core, right? We've moved to a modern design database. It's going to make it a lot easier to sort of iterate on these designs as we go forward. So that's really important to us. And the type of IPC gains we're getting, both in single thread and multi-thread, are really, really good, especially on the SkyMon E-core.
So we know that we have P-core, that each P-core has a cache, and also the E-cores have also a set of cache, and there's this whole hierarchy. So can you explain?
Yeah, I can break that down. Yeah, so we have the L3 cache, or L3 Smart Cache, and that has 36 megabytes, right, for the L3. In terms of the L2, it's obviously split between the P-core and the E-core. Each P-core has 3 megabytes of L2 cache, which is an increase from our previous generation. And then each E-core cluster, which is 4 E-cores per cluster, will have 4 megabytes of cache.
Mm-hmm. All right, so we're talking about E-cores and P-cores, but can you tell us a little bit more when it comes to performance, when it comes to IPCs? Where are we in the different types of cores that we have?
Yeah, so from a performance standpoint, especially from an IPC standpoint, from a line code perspective for like SNHX, we're seeing about 9% IPC. But the thing that really gets me excited and the team excited is some of the IPC gains we're seeing on the E-core, on SkyMon. And this will lead into a lot of the multi-thread performance that we will eventually be showing off and seeing in the future. But from an E-core perspective, right, there's obviously integer and floating point, two major things that we calculate. Yeah. And with regards to the IPC, from a single type perspective, on integer, we're seeing about 32% IPC improvement over 14th gen. Yeah. And on floating point, we're seeing around 72%. 72% IPC improvement. And that's, we took a number of workloads, about 6 or 7 workloads, and the average was about that. That means some of those workloads are higher. So, and obviously some were lower, but it's really incredible what we're seeing. And then from a multi-thread perspective on the SkyMon E-core, we're seeing very similar numbers. So again, 32% on an integer side, floating point side, about 55% Those are very large IPC gain numbers. And
very large. Those are huge.
Yeah.
And they're very,
so we're really, really excited about that. And again, this all comes back to being able to deliver incredible performance, but also save a lot of power. So, keep in mind, when we talk about these IPC gains, we're showing off these, really large numbers, but it's not really at the expense of kicking up the power. We're still going to be, up to 30% lower power than 14th gen. So this is,
so all these are
it's probably my favorite part of this whole story.
performance, and especially when they're double digits, it's great. And this is all compared to the previous gen, to the 14th
all compared to 14th gen.
No, this is amazing. You can see all the different changes that we have. Well, we have designed from scratch all the cores, and so you can see now how it's paying out.
Yeah.
Oh, that's great.
Really excited about it.
So now that we have the P cores and the E cores, and it's a different setup when it comes to Arrow Lake compared to Lunar Lake. We had fabrics that tied them together. How is it done here in Arrow Lake?
Yeah, so on Arrow Lake, it's similar to what we've done on products like Raptor Lake and Meteor Lake, where the E cores or the 16 E cores are on the same compute tile as the P cores, and so they're not sort of off the main ring, so to speak, where you can run the E cores on. The thing that we have in Lunar Lake, we can run the E cores without having to really power up the P cores, and that's really what's generating a lot of the power savings there. Not the case on Arrow Lake, but on Arrow Lake, it's much more about efficiency at power, when they're fully utilized and we're running on the CPU.
So you can say that they're like in the same ring architecture, or like of the same power ring architecture?
Yeah, exactly.
Okay, that's good. And the other thing that it was a little bit different that I saw is there's no low power island, right, on Arrow Lake?
There's no low power island on Arrow Lake S and HX.
Okay.
Right, so Arrow Lake H will still have a low power island, and we're going to talk more about that at a later date.
Yep.
But S and HX doesn't have a low power island, as is pretty typical for this segment.
So what is thermal envelope set up to for Arrow Lake?
Yeah, so Arrow Lake is it can scale all the way to 50 watts. So we have a PL1 that we're running at 125, and it can go to 250 watt. Very similar to prior generations. We are maintaining the high TDP that we want in order to get the performance associated with that.
So we have this completely new processor, right? This means also a new socket.
Yes.
Why is there the need to change sockets? Previously we have an LGA 1700, now we have, the new one is an LGA 851. Why the need to change?
Yeah, we would love to maintain compatibility forever. That would be a dream. But at the same time, we want to drive innovations. And when you bring new features, when you put new cores, when you bring an integrated NPU, when you drive certain level of innovations, you have challenges that coming at the package level, the signal integrity and others. Sometimes you need to route more pins, and that drives us for a change. That's in order to maintain the flexibility of bringing innovation, bringing new features. We sometimes being forced to do the change. We are trying hard to maintain at least 2 years compatibility. So we're trying to avoid gen over gen, year over year changes. But unfortunately, changes are required to bring innovation to the market.
We were talking earlier about the now how it's configured, the E cores and the P cores. How does the workload threading, or the thread director will be doing that? Is it the same as Raptor Lake, or?
Yeah, so there's things that are carried on from Raptor Lake that are the same. Some things are new. So there's some things in thread director that we're bringing to Arrow Lake compared to 14th gen that obviously we didn't have from 14th gen. First of which being is we now have E-core telemetry. Before, the feedback to thread director was just, hey, how's the IPC on the E-core? Now we're getting much more full sort of telemetry that we had on the P-core. On the P-core side, whereas we did have telemetry feedback coming from the P-core in the 14th gen, We've, I would say overhauled, but we've improved a lot of the metrics there and added a few more in terms of the telemetry feedback. And then the last thing that we're doing is we're being much more smart on core assignment to workloads. And so one of the things that we're talking about is sort of efficiency containments, where we can lock certain workloads that are running really well on very specific cores. And that's something that the Intel Thread Director is helping to do. So it's about, there's a efficiency gains we're bringing to the market with Arrow Lake. And then this feature on Thread Director is really just tweaking out a few more percent here and there when it comes to efficiency and performance.
That's pretty. I really like to see all those changes that we haven't seen in a while. So
Yeah.
It'll be interesting to see that. So moving on to, so that's kind of the overall of the core tile. Let's talk about a little bit about the GPU tile. So tell us a little bit more on that.
Yeah, so we're bringing the XE core architecture to the enthusiast segment for the first time. And it's actually the same architecture that we had on Meteor Lake, but obviously Meteor Lake didn't have the enthusiast segment products. And so really excited about that. Compared to 14th gen, we're gonna be greater than a 2x improvement on graphics. It's greater than 2x the compute capability as well from a graphics standpoint. So we're really excited about that. Yeah.
Now that's been interesting. So here's when we do a little bit of a fork on the road when it comes to the current products we're talking about. So we have the HX and S, and they're going to be using the XE, right? The current compute tile. And then for the H, it's a little bit different.
H is a little bit different. Yes. So on the S and HX, it's a 4 XE core with the XE architecture, great architecture. On H, it's what we're calling XE with XMX. And so there's some nuance there. One is obviously it's larger, so it'll be an 8 XE core instead of just 4 on Arrow Lake H. And it also will have XMX arrays. So what these are systolic arrays that are attached to each and every vector engine. So there's actually 128 of these arrays in the graphics core. These are AI workhorses. Right? They will greatly improve the AI performance. So on Meteor Lake H, for example, it was capable up to about 18 TOPS from an integer 8 imaging standpoint. On Arrow Lake H, we'll be able to go up to 77. So this is 4 times 4.
Yeah, that's pretty big.
The sort of raw capability from an AI throughput point of view. There's some other changes as well. We have twice the cache size. And it'll also be twice the ray tracing capability as well, compared to Meteor Lake H. So cache size, ray tracing, but the big thing that's really exciting us and exciting some of our ISV partners as well is the how capable from an AI standpoint the graphics tile is.
And I guess staying a little bit on the AI subject, this is the first time that we're seeing
an NPU
in
the enthusiast segment. Yeah, for Intel, exactly. No, this is something that's really a game changer. And there's it's not just about running large language models and things like that, which is very cool.
Yeah,
obviously. But it's also about a lot of these designs and systems that these products are in are gaming rigs, for example, right? And we're seeing the NPU and AI workloads work their way into sort of every aspect of life. And so, for example, we've got something that we've been talking about where, we can offload some of that work from, let's say, a gaming and streaming perspective, right? If you're doing, background removal or anything like that. AI workloads like that type of thing while you're streaming. Typically that kind of stuff runs on a discrete GPU that you're also gaming on, right? Well, now you can run on the NPU on your big gaming rig and you'll get 10, 15% better performance from your gaming performance.
Yeah, I mean, that's
pretty good.
That's really good because then
I'll take 50% gaming performance.
I'll take double digits anytime.
Yeah, exactly.
And it's pretty cool because then your GPU then actually can be dedicated.
Exactly. It can be dedicated to what GPUs were always meant to do, right?
Yeah.
Was to play all of my favorite games.
Exactly.
Yeah, exactly.
So one of the things that I wanted to ask you, going back to the graphics chat we're having, is why that separation, or why do we have XE and XMX on H, but we don't have that on S or HX?
Yeah. So with S and HX, these are our enthusiast top of the line type of systems, right? These are in your biggest and baddest gaming designs. These are in big, mobile workstations and desktop workstations and stuff like that. So, one of the things that happens in these designs, the vast majority of them have discrete graphics. And so there's really no requirement or need to have anything larger than something like a 4X core solution in those. Arrow Lake H, on the other hand, satisfies a lot of different segments as well. You'll get some designs on Arrow Lake H that have discrete graphics, especially in gaming and things like that. But to also like the premium thin and light and thin and powerful type segments where you want to run just on your integrated, and that's where we need that performance and power out of the graphics tile there.
That's awesome. Yeah, that completely makes sense.
Yep.
So going back to memory, so we haven't improved the memory, the bandwidth, and make any changes there?
From the system memory point of view? Yeah, so we've actually increased the memory speed that we support up to DDR5 6400. It comes in all forms, UDIMM, CUDIMM, all that stuff. We also obviously support dual bandwidth memory support, as is typical for the segment, and then we're actually offering ECC support for more secure, security conscious designs.
A really cool thing, a little history on Arrow Lake. We first started talking about this back in 2019, working with Intel's memory architects, the overclocking team, and we set some very aggressive goals. And for the first time ever, we set these, 5 years out goals. Specifically, we created a new tiered system. We have a tier 1, 2, and 3. Internally, we have goals and targets that we're all aligned to achieving. And so we've said we want to reach these different goals. Some of them are for the average everyday XMP customer, some of them are for the more aggressive air-cooled overclocker, and some of them are for those folks that are out there setting world records and reaching new heights. Super proud of the hard work done by the memory architects at Intel. They put together an amazing new memory controller, brand new from the past. It is capable of reaching higher heights overclocking-wise. We have the ability to support technology called CUDIMMs, and from an overclocking perspective, we're seeing just incredible results. So a CUDIMM is very similar to the traditional UDIMM, but one of the main difference is that there is a redriver, what we call a clock driver internal to the memory module. And so it will generate essentially its own clock, nice and clean, and that can enable higher speeds, especially for those kind of mainstream and low frequency XMP levels. Regardless of some of the characteristics of the motherboard that could be an impediment. So like even lower price point boards could actually really benefit from this.
All right, so this is an enthusiast product. So of course we have to start talking about overclocking.
Yeah.
What is new? What does Arrow Lake bring new to the table, to the overclocking table?
Yeah, okay, so, we're not really gonna talk about, how much frequency.
Exactly.
But we are bringing a ton of new features into how we overclock.
Arrow Lake has a tremendous number of new overclocking capabilities and features. See, having a new architecture, the new SoC, a multi-chip design, presents new opportunities for overclockers. So we have a lot of new features. Right off just knowing that we now have multiple chips, how about the ability to overclock the interfaces between the chips that are talking to each other? So we have a new die-to-die overclocking feature that's really exciting. Die-to-die is an interface that is between our compute die and our SoC die where the memory controller resides. And what's cool for overclockers is now we're allowing you to overclock that interface, creating a whole new opportunity to improve bandwidth and further tune your system. We have a new feature that allows you to configure the processor's overclocked ratios in 16.6 megahertz steps. In fact, they can be larger, but 16.6 megahertz is interesting because now overclockers can move in sub 100 megahertz steps. So now overclockers can configure each core for P cores in 16 megahertz increments, and their E cores, each group of 4, can be also configured in 16 megahertz increments for those top frequencies. So imagine you reach the end, what you thought was the end, because you couldn't go another 100 megahertz up. Well, with this, you might be able to go 16 or 32 or so on to find where that absolute max threshold is for your system. We've got a new dual B-clock architecture. Now, everyone knows about B-clock going back 20 years. There's generally always been a single B-clock input. That's your base clock. Now we have dual B-clock. And that is helping us because you can now have a separate clock frequency for your compute die versus the rest of the chip, the I/O die, memory, etc., which is really important because when it comes to B-clock overclocking, you're always at the mercy of the first subsystem to fail. So by being able to separate that into dual B-clock, you essentially can have one section of the die of the processor at a higher frequency than others. You can have, for example, one external clock and one internal clock, or you could actually control them both internally. So it gives you a lot of flexibility, a lot of choice. Now we have the ability to do fabric overclocking on Arrow Lake, another opportunity brought by the new architecture. This essentially can improve the communications within the SoC die itself. And when you're doing memory overclocking, you may choose to overclock the fabric, die to die, and then of course the memory frequency as well to ensure that full bandwidth without bottleneck exists.
We also have something called DLVR bypass. So this is one of the more higher end, sort of higher tech type of features. It lets you totally bypass our automatic voltage control.
DLVR is Digital Linear Voltage Regulator. And it is a new power delivery architecture for desktop processors. And it brings with it some great efficiency benefits. So that power efficiency is there. And it can allow the opportunity for overclockers to essentially have per core voltage. So for each P core, you can have its own voltage, and for each group of 4 E cores, you can configure a voltage for those as well. So it's added flexibility. You don't have to run them all at that same fixed voltage. For our extreme overclockers, people looking to go after world records, that top 1% of all consumers, they can actually bypass DLVR. Again, it's overclocking, it's extreme overclocking. We expect to see that done with like liquid nitrogen, but you can bypass it such that your voltages can go, even higher and enable, those maximum LN2 liquid helium type frequencies. Arrow Lake's new overclocking features are available also within the extreme tuning utility. Specifically the 16.6 megahertz ratios, the dual B clock, viewing the memory telemetry and a few settings as well. All these settings can be found in the XTU user interface. So for me personally, one of the things I'm excited about with Arrow Lake really are the new 16.6 megahertz ratios. It's actually hard to pick a favorite, so I'll just also have to say exploring that die-to-die interface, overclocking, and the fabric overclocking as well. And I think for me, on the memory overclocking side, I'm going to get some modules that can run at that 8,000 megatransfer range, but that have headroom so that I can push them a bit further. I'm going to really go after that 9,000 plus range over time, so we'll see what I can do there. But I'm just really excited to really get a handle on and explore these new really customizations that I can make that were never possible on prior generations.
What is the thing that you're most proud of when it comes to the development and launch of this product?
It's really the team dedications. Arrow Lake was a product that we execute to pretty much around the globe. We had major sites. There are many other sites. Intel is spread around, but there were 4 major sites contributing to this amazing product. We have team in the US, we have team in Malaysia, we have team in India, and we have team in Israel. And those are major teams, different IPs, different functions. And if you look at the time zone associated with that, it's just crazy. But yet, the team put it together. That there was really creative ways, automation, and hard work that really bring all of them together and deliver an amazing product. So the team effort and dedication and the one Intel that came across in this product is by far the things that I'm most proud of.